Project is to implement a dialog system which answers the user's queries related to product information. We have scraped data from Flipkart's website. Flipkart has the product information neatly represented in a table. Out of all the properties that are available on its website, we have selected the most commonly asked for properties. We have used Scrapey to scrape from Flipkart.
Project into 5 modules. The first part is scrolling and scraping the product from the Flipkart website. We have used Scrapey to scroll the data. We scrape the data for 3 categories, namely mobiles, laptops and televisions. And we have created a spider that crawls the data from the previously shown tables on Flipkart. And we use this spider as start spider, which we have put our spider in it. And it will use a request object that will request for a URL. And Scrapey will use the request object to request for the URL of the above categories. The request gives a response object that contains the HTML of the URL requested. Then we scrape the data using the tool known as Beautiful Soap. And let's see the example where in scrape data for laptop we have used Beautiful Soap here, where we are passing r.content, mean that the URL, the response object that will give the URL, that will give the response, and Beautiful Soap which will extract properties of the product from the scraped HTML pages.
For the scraped data, we need a database which is capable of storing big data. For this purpose, we chose Cassandra, which is a NoSQL database. This database is designed to have 3 tables, one for mobiles, one for television, and one for laptops. As you can see on the screen, this is the schema of the mobiles table. Then you can see the properties here, which are the columns, the model name, the battery talk time. The model name is the primary key, the battery type, Bluetooth, OS, and etc. And this is the schema for the television table. Here also the primary key is model name. Then this is for laptops. Database, next comes the pre-processing of the query. For phase 1, as of now we have handled property-based queries using a template. The query syntax is first comes the product name and then comes the property. The approach we followed is we maintain 3 lists, namely the product list, the brand list, and the property list. As you can see, this is the property list, which has architecture, battery talk time, which covers the properties of all the products. And this is the brand list, which is very small. Here we take the input from the user, and then the input is in this format. First comes the product name and then the property. And then initially we have extracted the brand of the product from the given query by iterating to the brand name list using an algorithm called edit distance. We chose this algorithm because it also helps in correcting the typos entered by users. Then coming to elements of product name list are tuples of size 3. The contents of this tuple are brand, model name, and category. So now, after the extraction of the brand name, we consider only those products from that particular brand for further processing. Then, for determining the exact model name and the property name, we use a similar approach as discussed above, like the edit distance one, but we add another similarity measure.
The measure that we have used in this case is something similar to count the number of characters which are similar in both the words and store it in a variable, and then we take the max of the lengths of both the words. So once we have both of these, we divide the max length of both the words by the total number of words matched, and suppose that the total number of words matched is 0, then we return a very large value. So once we have taken the similarity measure of this similarity measure and the edit distances, we take the harmonic mean of both these similarity measures. So this will be our final similarity measure between our query term and the product which is in our product name list. So we iterate through all these products in the product name list and find and find the similarity measures. So once we have done this, we sort this list and take the top 10 entries, which will give us the most relevant entries in our list. Similarly, we use the same approach for extracting the property from the property list. So once we have the brand, the exact property, and the exact product name, we simply query our database. So we also know which category the product belongs to from our product name list. So we query the appropriate table to get our required results. And the system design or the architecture that is involved can be seen on your screen. So we have a query processor, and the Cassandra driver will basically interact with the database, and the crawler and the scraper will get our data from Flipkart and store it into our database. Yeah. Okay, so let's run a few queries. So the syntax of our query is product name comma property. So suppose we would like to see the price of iPhone 6s. Apple iPhone 6s comma price. So you can see that we get the top queries, and so in a later stage, if we have an exact match, we can directly output the price, and if there is not an exact match, we can give out a list like this. um, this method would also work even if there are a few typos, like let's say we type iPhone like this, and let's say 5 this time, and let's say price again. So you can see that we still get Apple iPhone 5 as a top result. A few more queries could be, let's say, Samsung Galaxy.
It's 10 o'clock.
S5 comma resolution, which would give us the screen resolution. So as you can see, the top result is S5, which is a direct match, and we do get the right results. We have also built a UI for our system. We handle 3 types of queries. The syntax type of queries that we have just shown you, comparison based queries, and natural language queries. Let me show a few of them to you. So we've just seen syntax based queries, so let's just see one more. S3, and let's say we want the price. So as you can see, the top result is that, but we also give you a list of the next most relevant products. So that was our first type of query. Now coming to natural language queries. Let's say, what is the resolution of Apple iPhone 5? As you can see, again, the first result was very accurate, but we still do give other results which are most relevant after the first result. So this, and the third type of query will be comparison queries. So let's say we want to know which among Samsung Galaxy Note 2, Apple iPhone 4, and Apple iPhone 6 has the best screen, let's say best size, like as in, or let's say best resolution, So yeah, so Apple iPhone 6X is the best resolution. Thanks.